Alrighty, let's talk a little bit more about agentic AI. Now, in the afternoon session, I want to be a bit more on the practical things of things you can actually learn, take home, do yourself. So I'm going to talk about essentially three things. I'm going to talk about how to pick the right large language model to write Qt applications. I'm going to talk about, or at least show you how we are fine-tuning and doing prompt engineering for the models to write better QML code. And then last but not least, I'm going to a little bit debug the agentic AI demonstrator I showed in the morning, telling you a little bit of, or showing you a little bit behind the scenes capability of what is the AI currently capable of doing and where does it need to still improve in the coming years. So does this even matter for anybody? I mean, essentially, is this all just a hype? And if you talk, or McKinsey did a study on studied with companies in terms of how much are they using Gen AI in business, and 71% essentially said, yes, we regularly use Gen AI. So now one could say 71% is quite a lot, but then again, hasn't the other 29% used ChatGPT or something like that? Maybe it has to do with the regularly, but let's say 71% is quite a lot. So one would say in business, it's very common to use Gen AI. Common statement, McKinsey just doing a study in March 2025, so it's pretty new. How is it about the business we are talking about here? Software development, software engineering. How does it look like there? How much people, based on the research from McKinsey in March, are using that one? 71% is the starting base of all, 18% only. Only 18% of respondents in this research said, hey, we use Gen AI in software engineering. Why is it so little? Why aren't we all like vibe coding away, hoping Gen AI to write our code? Only 18% out of, the starting number was 71. Everybody has tried, and whether the cursors, GitHub Copilots, whatever AI assistant tool of your favorite. This is a surprising little number. So what might be the background be for such a low number of people, at least openly saying, we use Gen AI in software engineering? There might be one strong reason why people respond like that, and that's, I think many of you are developers, and having talked to many of developers, particularly QML developers, in the last 9 months when we designed the Qt AI assistant, we got consistent one feedback from the developers, where they want to use Gen AI and where they don't want to use Gen AI. And one of the things they clearly said, we don't want Gen AI to write my code. Well, some of you can agree, and there's a lot of ifs and buts right away coming after that. First, we don't want Gen AI to write my code. Well, the repetitive code is fine. If I write a text field like this and I have another text field just coming after it, why don't you just take the same structure and anchor it correctly and we move on? That's nice. And then they come talk about unit test cases. Yeah, that's not really why they got into the business either of writing great code. So yeah, unit test case, code documentation. So it becomes like, okay, we're using it more and more in various areas, so that's fine. But very much you find the consistency in all research that you look at. Writing software for production is one of the lowest use cases where developers see Gen AI helping them. So why might that be the case? And what does that mean? I mean, what are the other challenges that they are? I mean, an attitude, or it's not considered being helpful, is one of the pain points. What are the other pain points that people see in terms of Gen AI helping people? And another reason why they might be hesitant, why we are talking only 18% in software engineering, might be that as well, that the large language models that we know today, the OpenAIs, the Anthropics, the Claudes, the DeepSeeks, you name it, Mistral, if you want a European one, they are typically not trained to write Qt code, Qt C++, QML code. That's not what they're being. That's never the focus, or seemingly not the focus of these big players that are competing in the area of code generation, but they're competing on one and the same language, all of them. And that's Python. Essentially, they are all, when I come out with a new model, new version of the model, everybody does the benchmarking. There's benchmarks called human eval, which is entirely Python tasks, or then you have the mostly basic Python programming, MBPP eval. These are the statistics they're publishing with the release of the new model. It's called mostly basic Python programming. So yes, again, Python. So these models are not optimized for writing cute code. Not surprisingly, that's why a lot of people might be hesitant to use them. And there's a third challenge, and that comes typically out when we talk to product managers, to companies that have a lot of intellectual property, have their competitive advantage out of their user experience, their brand, the way they are doing things. Very often they say that as well. They consider a challenge of creators being concerned about the IPR, right? I mean, you essentially still, for whatever you do, typically when you do code completion, you're sharing part of your code for Gen AI to help you with the next level of code. Or if you're asking, create me some new code, you give the project information as a background to move forward. So we find a lot of customers, not only in the regulated businesses, but also in all business, just being worried about the IPR. Whether it's reasonable or not, everybody promises you not to use your data for training. But then again, for reality, if you tried, for example, ChatGPT and you put it even on temporary mode, that it forgets the conversation right away, they will tell you right from the beginning, they will store your data for 30 days, just in case for safety reasons, right? Okay, they're not doing anything with it. But there's a concern. So again, that might be a reason why people are not using Gen AI more than they could be using. But this also then drives for us, for Qt, our mission is to help you, developers, architects, testers. Our job is to help you to be more efficient, to be more productive. So we thought, okay, how can we overcome some of these challenges? How can we help you? And let's start with just the most basic task of a software development, code completion. This is where GitHub Copilot started with it, just plain code completion. And code completion as such is not new, right? I mean, you had static code completion, completing a word or an object, like a QML object, existed already for quite some while. But now, of course, Gen AI helps you to do more like things that takes the whole context into account. So here you see, for example, the Qt AI assistant doing a code completion on the radio button. And it's essentially, okay, it understands what's the prefix, so everything, all the code before the cursor. What's the suffix? All the code behind the cursor, which in this case is just a bracket, but nevertheless. And then it tries to guess what should come between. And so the best guess in this case is we'll do another radio button ultimately. And we did some benchmarking of how good systems are in this code completion. We started with this one pretty much in end of 2023. We started with benchmarking large language models because we noticed they are different in their skills. So we are constantly looking at the benchmark test. These are 100 tasks of code completion, where we always show here's the prefix of the code, this is the code after it. Try to guess what could be correct code in the middle. And here you see the results currently. So you see most of these mainstream large language models, they're similarly good, yeah, right? I mean, everybody essentially gets pretty much half of the right. There are some models like just tested last week that I haven't put in here. For example, GPT 4.1 mini, that has only 48%, so we're not going to even support that as a configuration. But most of them get half of them right, but some of them are clearly better, right? I mean, we're still talking about some models getting roughly 60% right, and then some models getting 2/3 of the suggestions right of something meaningful that works, that compiles, meets the QML standard. So, and the clear leader here until now is Claude 3.7 Sonnet, that essentially has been for 1.5 years clearly best QML coder around, and consistently beats the other models as we go forward. But Sonnet got a challenger in this business area, in writing QML code. And there's one new leader in the benchmarking board. Who might that be? The new leader's got an 87% of successful code writing. And it is actually our friends from China. So they're doing something right. So DeepSeek has become, according to our 100 coding benchmarking tasks, the leader in writing QML code. And it's not the reasoning model, it's actually the core model version 3. They are the best currently out there. And you see there's a lot of mix. There's some royalty-free models. There's models for free. So it's not that easy to choose your right model. But because DeepSeek is good, and JP talked about in the morning as well, that we Qt believe in an open tools, open framework technology, we decided to support also DeepSeek version 3 in the Qt AI Assistant. So today we are announcing, and I think we're publishing the software release as I'm speaking now here. We're publishing a new version of the Qt AI Assistant, and we're supporting now DeepSeek version 3, and together with also now supporting 3.7 Sonnet. We are publishing just the release within these minutes. And everybody, especially our colleagues in China, have been asking for a lot. We have a massive community of Qt users in China. They, of course, want help from something that understands Chinese, so we're supporting that one as well. So there's a lot of options, and this is just an older screenshot from the Qt AI Assistant in terms of the LLM configurations that you have. And there's multiple choices for code completion that you have, but how do you choose the right one? What's the best for you? So I want to give you a couple of decisive criteria or decision criteria that might influence your choice. At least you should make an informed decision. So size matters, right, or not? Well, in terms of LLMs, it's not that clear. What you're seeing here is that a locally running, a CodeLlama 7B, 7 billion parameters, pretty small, or a DeepSeek Coder version 2 Lite, also with a few million of parameters only, running either in cloud or locally, they are as good in writing QML code than GPT-4o. I don't know how much billion parameters GPT-4 has, but if it's less than 200 million, it would surprise me. So some models that are fairly small, some of them they can run on your GPU-accelerated computer, they are as good in code completion than when you connect it to OpenAI in the cloud. So you see really difference. And these are still the base models of CodeLlama that are doing fairly well, or DeepSeek, generating code, giving you a suggestion. So size doesn't always matter. You can pretty well deal with a local one as well, going forward, helping you to write your code. So what about, should I run it locally on my computer, use Ollama technology as a hosting technology for large language models on local platforms? Or should I place it in the cloud? Well, there's, of course, a lot of decisions going into it. Is it your own cloud, your own private data center? You can run their CodeLlama 13B, host it for all your developers, spend one A100 NVIDIA piece of hardware on it and offer it to all your providers. Only you using that large language model. Do you want to have a convenience of just buying it in there, no friction, buying it in as a service, buying it from Anthropic, OpenAI, or DeepSeek? Or you want to run everything local, like you're used to run your IDE locally, your Creator locally, your Squish locally, you want to run your LLM locally as well. So there's a lot of decision criteria going in there, and there's different benefits and disadvantages. But currently, from Qt, we wanted to help you as well in having more options. So as I've shown earlier in the benchmarking results, the CodeLllamas are fairly good, as in base model, but they're not quite as good as the big models, the general purpose models, especially as Sonnet. So what we did within Qt, we essentially started fine-tuning these models. And we are offering by now 2 different models, free of charge, royalty-free for open source developers, for anybody, or users of the Qt AI Assistant. We are offering 2 models that are fairly good in writing QML code. One of them is a cloud-based solution. That's CodeLlama 13B/QML. You can find it in Hugging Face. You can run it in Ollama, but probably, well, you've got to have a really powerful machine. My computer always starts running the fan on a level that I'm thinking about baking a pizza soon, so I'm not running CodeLlama 13B on there. But this is a model that's designed. It's a mid-sized one, runs on essentially, I would run in the cloud on a single A100 NVIDIA hardware. And that's one option. We tuned it with over 5,000 pieces of QML code. So these are little QML apps or snippets that we are using for training this model. And then we have this is for cloud. Then we have a model that runs locally, which is our little llama. That's the best model for code completion running on Ollama. Again, trained it roughly on the same 5,000 pieces of QML snippets. that we have created. And that's another model we're offering for people that like to run everything locally. It's not quite as good as its bigger Llama brother, 13B, but it's still very, very good. So how do we do fine-tuning? What are we doing here? I mentioned over 5,000 pieces of examples. So what are we actually doing? What we are doing is, in reality, currently we have 5,700 code snippets. So these are little pieces of code. I'm showing you a couple of examples in a second. That's the starting point. But this is not where it ends, right? Because I said for code completion, what we're trying to teach the model is guess the code between the cursor prefix and what's afterwards. So we can use these 5,700 code snippets and place the cursor almost randomly at any place and show it then, if you find the cursor here, this is the prefix and this is the suffix, guess this is the following one. So we can almost indefinitely multiply the 5,700 snippets by just placing the cursor randomly within any of these snippets. But of course, this is not an endless show, and there's some cost, and I don't have a nuclear power plant available for training or fine-tuning. So what we're doing is, I think we're creating out of each of these 5,700 code snippets, we are doing, I think, 40 examples, placing the cursor 40 times almost randomly. We have a logic that we try and error. We have a logic of where we place the cursor to have a certain set of word completion, line completion, structure completion, object completion. We're placing it with a certain ratio in there. But that gives us then already 220,000 training samples. So that's already rather decent to go in there. So now you have 220,000 pieces of QML applications that you're coaching your model in terms of, if you see this code, your best guess is doing this. But this is not, so how much lines of code is that? Depends, of course, on how big the snippet is in average, and there's no average. But we've counted that it's roughly 11 million lines of code. And if you think about Qt Essential being 3 million lines of code, this is not bad. So this is already a pretty decent starting point. So we're putting into the system 11 million lines of code. And if you know Gen AI, and you have paid for Gen AI, you know that the actual currency is tokens. So if you convert the 11 million lines of code into tokens, we are ending up with a whoopee 85 million tokens that we are training code llamas with in getting better. So that's already a pretty decent amount of data to just bring in and going forward. But what kind of data is it? What is a typical code snippet? And like I said, there is no typical one. This is the most simple one, right? I mean, it's not even particularly useful, but I kept it in there because it's one of the symbols that we have. It tells a little bit something about how a button is structured. But this is the easiest one. I mean, this is not rocket science, like real use. Well, probably would never write a thing like that, but it tells the model something. So I kept it in there for example. So this is, I think, the easiest one that we have in our code snippets. But then this is one of the more complex ones. And I turned it sideways because I know the developers among you, when they see code, they go right away in the code review mode and trying to find the bugs that we have in there. So I made it a bit more difficult. Turned around, made the font almost impossible to see. So, but you get the size of the code snippet, and this represents just this one. This is a speedometer control with a slider at the bottom with gradient colors. That's just one of the more complex things that we are feeding the model as. This is a typical UI control, right? You might use that in your UI. You might have to create it. So this is what we are feeding to the model as an example. So it's anywhere in between what we're actually giving it going forward. And after having done so, let's look at the benchmark now after fine-tuning. What we managed to do is actually get a 20% uplift to the code llamas. And the code llama 13B is now almost as good as the leader of the Java. So now we're getting 86%, so 20% better performance in code completion with our fine-tuned model in writing QML code when you're in code completion mode. So that's pretty decent already, because if you think about, I don't want to know how much money Meta needed to use to get to the first 66%, but we are adding with just 5,700 code snippets, we're adding another 20% to it without having $100 million available and without having a nuclear power plant to run this thing and the training. It's pretty decent. So we're getting pretty high. And essentially, these models are now available for anybody of you, royalty-free, and you can just download them. For code completion, they're very, very, very good. as we speak. So this is something we did. We decided we want to help you guys getting forward. We want to help everybody, so that's why we made them available as well for open source developers. So these are currently the amount of choices, and you see that they are getting pretty close to the big guys as well, but even not even on the same level. I mean, as a matter of fact, our code Llama 13 BQML is better than Sonnet Auto. For sure, there has been a lot of time used and money used to create that one. But code completion is only one skill such an AI tool, an agentic AI needs to do. A lot of things that we are used to, and it started with this revolution of Gen AI, started with ChatGPT, right? Asking with human language, can you write me the code for a radio button that changes the color of the indicator when being checked? Natural language-based prompts, code generation is another skill that is very different. And so we did rate for that one. But of course, even asking for it to write code is only one skill. So we could say that that's just one agent writing code based on a human language. But there's other agents that essentially you need, or agentic skills you need to have if you want to be a good coding assistant. And that is totally different skills. You need to be able to write test cases, you need to be able to write code documentation, lots of different skills that you need to bring in and explain code, fixing code. It's a different skills, and we see that, and we're benchmarking models as well. How good are they in these different skills? But prompt-based skills are, again, very different, and you need to look, again, individually at these models and their skills. So for prompt-based code generation, we have our own benchmark. It's, again, different. And this is the score of what we see currently. As you see, the smaller models are not doing well here at all. A small Llama model with 8 billion models, 13%. Starcoder 2, 15 billion model, already mid-size, only 80%. So there you see already much more variation between the big models and the small models, between the general purpose models and the essentially targeted, specialized models doing one particular thing. So there you see already, if you're just asked with a prompt, generate my code in our 100 tasks, you see already there's much more difference going forward. So how do I decide then on what's the right model for me? Do I decide on country of origin? Well, if you're in China, I know what you're picking. If you're in the US and you care about having a model in the US, well, for me, 3.7 Sonnet, or well, this slide still says 3.5, would be my choice. But the Europeans, well, not so well off. Mistral Large is not that good yet. I mean, this is a model that was just published recently this year, and as you can see, it only does roughly 40% of getting the task right. So currently my guess, if I would be Europe, is still, I would be hinting you towards Sonnet if you choose to have a model that runs in a cloud. So country of origin is still a very difficult choice. If you have a preference, political, geopolitical, for whatever reason, country of origin will be challenging to find a good model because performance is so different. What about transparency? Right? I mean, are you interested in what kind of training data has gone into the model you're using for writing your production code? So transparency is another thing, but that's where the world is very sad still. Out of all that models that I had in my benchmark, there's only one in there that you can look at the training data. That's Starcoder 2, the 15 billion model. That's the only model that actually has QML code in there, the 15 billion model. The smaller models don't have it in there at all. And even then, it's not very good. So if you're planning for 100% transparency of the training data that has gone in there, choices are really slim and beyond that. So really tough to have transparency as decided. So if transparency doesn't help us and country of origin just helps us so much, what should I choose? Should I choose reasoning models or the original underlying base models? Well, typically one says, of course, the reasoning models, the ones that have chain of thought thinking, they're planning first how to write the code, make up the code, write the code, rethink whether the code they've written is any good, and then only publish it as a result to you. Typically, you would say, hey, they're the better models. Turns out, in our tests and our benchmarking, yeah, it's true. O1 is 9% better than GPT-4o, so yeah, reasoning is better. It burns a lot of more tokens, of course. You have to remember this additional 9% of completion success comes at a price tag. I mean, reasoning burns a lot more tokens and a hole in your credit card if you use it. But even for DeepSeek, it doesn't work like that. It's actually the reasoning model is worse in writing QML code. We did look at the code generated, and the main root cause for reasoning models being worse in the benchmark is they're trying too hard to create a lot of long examples. And as you know, as a developer, the more code you have, the more bugs you have. So they fail more often in the benchmarking. But this is how it is with these reasoning models. They're trying to be outsmarting everybody else by coming up with super ideas, as much complementary data and code as possible, and they're not necessarily the best. So again, you need to be cautious if you're in China. You need to be cautious of what you're picking. So for us, what we'll announce today, we are doing actually the version 3 support. We're not supporting DeepSeek R1, which is the reasoning model, because it's just a better one. We want to provide our customers the best option, not just any option. But it still remains hard to find a good model. I mean, these were just some of the input factors, and I talked earlier about locally and cloud. Of course, in these prompt-based ones, you don't even have that choice because the local ones are not really good, so you can choose somebody else's cloud or your own cloud. These are the two choices that you can do. You can run, for example, a CodeLlama 70B instruct if you have enough hardware. If you're happy with 40% successful completion, sure. You can run that in your own cloud, then all the data stays in your network. But otherwise, your choices are still very limited when it comes down to prompts. But again, creating code based on a prompt was one of our agentic skills only. There's other skills that you need to learn, and we are trying to help you out there by what we can do, prompt engineering. It's not very easy. I mean, we've tried quite a couple of times to train these big models, like CodeLlama 70B, to be better in writing QML code, but it seemingly we haven't found the right recipe, don't have enough training data, or both. So far, there's not much we could do. So what we're doing is at least we are doing a lot of prompt engineering, trying to find out what's the right instruction to give when we are creating an agentic AI agent that is, for example, creating unit test cases, squish test cases, doing code documentation. We spend a lot of time on prompt engineering. But also there's a different level of complexity. So this is, according to the Qt AI system, this is the most simple prompt that we have for fixing the code. Just based on code that you highlighted, with a cursor, fix me what's in between, just focus on fixing, don't come up with other stuff. Mark down the code as code blocks so we can then show it correctly and you can copy paste it or insert it nicely. This is what we do. And actually we have changed this one already. By now the sentence focus on code changes. We removed the without introductory text because actually we found that it's quite useful. So this is also living all the time in a Qt AI assistant. But this is the easiest one. You want to see the hardest one or the longest one? This is for creating Qt test task. So again, will be a bit difficult to read out that. But I highlighted the number of instructions there. It's 47 when I took this a month ago. So this helps you to write a Qt quick test. This includes anything from do this, do that, don't do that. If you see this code, do the following. So it includes anything from giving examples how to write the code to do this or don't do that. So by now it's actually, we have over 50 instructions. So it has grown a little bit. When I took that screenshot, it was 47. We have 50. So this is this is the most complex prompt we have. So it took us quite a while, a lot of iterations to get there. But it starts writing good Qt quick tests that you can take and run with. So on these 50 test cases do exactly this. They write you this test case, Qt quick test case. Here in this example, you just highlight the code, you enter this smart command Qt test, and then I think this was Sonnet creating that one, generates you the test case that in this case repeats you still the original component. You could of course link then to the component to be tested, but there you see then the property test cases, the signal handlers. So it does all these, and you can then copy paste this one directly into your test project, and with that one you're essentially ready, set, go for your Qt quick test for the components that you've highlighted, or you highlight the whole file and it will do you the whole file. But it takes a lot of instructions to get this right. And we have actually, for every model that we have, so at least for DeepSeek version 3, OpenAI, and the Anthropic models, we have different prompts. So you cannot just copy paste and hope for the best. So every time you need to look at what works with this model. But where does that get us? I mean, what is the future of large language models looking like, in particular when it comes down to giving coding assistance for Qt? There's a lot of things that you need to take into account, and there's a lot of discussions in the industry what the future will look like. And one of the polarizing topics is, do we see more expert models that are good in doing one thing? Like, if you're a senior QML developer, a senior embedded developer, I'm sure you're the best in the industry in your field of writing that code, but maybe you're not the best in everything. And this is the same here. Models like CodeLlama 13b, they're very good in writing QML code after the fine-tuning, but they're not so good anymore in writing C# or other things. And then there's, of course, the other fraction of people say that we are talking about AGI, multi-purpose models like the GPTs of this world or Claudes, all the ones that are racing towards there will be only one ChatGPT, like Google Search, ultimately the winner takes it all, and they're betting on there will be only one model in the long run, and specialized models don't have a chance for the purpose. I don't know where it's going to go. I don't have the crystal ball. But this is at least two polarizing opinions that you find. Some industry players, of course, have a financial reason why they're looking at certain benefits. But there's benefits, pros and cons for each of these models. Small models are, of course, much more cost efficient. Like I said, even a 13b model you can run on a single A100 chipset, and a CodeLlama 7b, which is pretty much up there as well and being as good as the Sonnet model. You can run even on a local computer. So if you have something a little bit newer than I have with my 3-year-old Mac, you can run that with good conscience without only creating heat. You can fine-tune them much easier. You might think about as well, if Qt Company can fine-tune with 5,700 code snippets, I might do that for my purpose, for my medical device, for my cockpit, for my Thermomix, whatever. At this size, you can with reasonably cost still fine-tune. You're not going to fine-tune a 400 billion parameter model just out of the box. And of course, they're private, right? They are yours. They're running locally. But multi-purpose models are convenient, right? This is the no friction that Chris Barton talks about. They're multi-purpose. They can do all of the things to larger things. And then, of course, they're a shared resource. So these are the things to keep in mind. But if you think about choosing LLMs, that's, of course, only one thing. How are these processes and the different agents coming together? And essentially, we see currently 3 major models of how the future of code assisting will look like. If you talk about multiple agents that look up your repository data, take that, and you can look into potentially in the internet for additional information, do code documentation, code generation in one go based on the task. These agentic solutions, they might come in 3 different solutions. One of them is an agentic IDE, so like Cursor with its agent mode, Copilot with its agent mode, or the demonstration I had in the morning. These are all agentic IDEs. The single source of truth being your QML code, it lives within the IDE, and they are then triggering and calling the different agents to solve multiple problems. But that's not the only actually way that this may play out. If you're Atlassian, if you're having something like Jira and you have a task management solution, you actually might say, I want to be the orchestrator of it all. So that's a totally different approach than these agent modes that we've seen in Cursor, Copilot, and the Qt AI Assistant demonstration in the morning. Why don't you have somebody like Jira orchestrating the task and the workflow between the different, well, I guess you hate the workflow in Jira, but organizing the tasks in this agentic AI. And there's still a third method that Google just published recently in open source model. It's the agent-to-agent collaboration. Why don't you have one master agent that's telling all the other agents, based on your human input or the image you want, solve that problem to me. And that master agent is then instructing all the other little agents what they need to do. And that's what is called agent-to-agent collaboration. So this is the workflow that essentially I went through in the morning. So it's a workflow where everything resides, and the workflow manager is within the IDE, such as Qt Creator. It starts always with, in this case, it could start always with a design. If you're doing an iteration of something existing, of course, it starts with something existing, and you take then what's the mission, what do you want to change. It goes then through different agents, whether it's conversion, design conversion, review agents, creating the documents, code generation, whatever you need, static code analysis, whatever agents you need, it goes through them, but it's the controlling logic is the IDE. That's where the workflow managers, maybe in the future you have visual kind of workflow managers that you're just dragging nodes of which agentic AI component you want to help you in which workflow. Could be one way of doing it. But the other way of doing it is what I'm showing now, is of course something like Jira's or Atlassian's Rovo models. These are orchestrators calling different AI agents and doing the job. So now you have standalone island solutions, and you can call them from a centralized task management solution. It might play out ultimately that this is the way the future is going. That you're using Jira not only to manage, like, okay, to do in progress, ready for code review, ready for PO review, ready to release, but it also might trigger then actions in AI agents. Maybe this is how it's going to play out. I don't know. It's something, of course, different players have different interests in terms of how this is going to work out. And the third one is really then what Google just recently introduced, a nice protocol, open source, is an agent-to-agent collaboration, that you have a master agent that has this large language model attached to it, and that instructs always either the next one and the next one and the next one what they're supposed to do, or it works as a center of gravity and instructs them in a star configuration. I just drew it here in a line because I had drawn my things in a line. But it could be, of course, a star configuration that you have a master, a main, I need to say main notice. It needs to be a main agent that is then orchestrating the whole agentic AI to get to a certain goal. Again, we don't know what's the winning solution, and maybe there's different ones that come around. But there's one more thing I want to talk about in terms of at least theoretical level, is of course the levels of AI agent autonomy. How autonomous are they? I mean, if you think about the original copilots, cursors, Qt AI Assistant, they're all single tasks, single instructions. They have no autonomy per se, right? You tell them what to do, they will do it, try to do exactly what you have, like a happy internal assistant that's just around 3 months in the company, and they try their best with the knowledge what they've learned in university. So there's 3 levels to this that we can think of. One is, of course, very simple, single task, what I mentioned. This is what everybody started with, and we're seeing now the first agent modes, but even then, the next level is like guided execution, but multitask, right? They will do multiple things. They might try to get towards a certain goal, like generate me code or fix this code based on this bug. In order to fix that, they might decide to look at some repositories in GitLab or GitHub that you have. They might look at the internet of where it finds information of how to fix the problem. But that's very little independence, and mostly if and then clauses. But this is where already some level of autonomy may or may not occur. Currently, we see very little of this, and most of it is deterministic, so if and then clauses ultimately. But that could be the next logical level of execution, and I think some of that we will see eventually going around. And the last one, that this is, of course, the promised land of all the preachers and all the NVIDIA CEOs, that essentially like independent execution, self-tasking agentic AIs that essentially just say, hi, I need a consumer-drawn UI, can you do one for me? It needs to have this and that and that. And it figures out what it needs to do, which agents to call, which problems to solve, what tests to create, and it solves all these issues on its own. Well, it's a little bit futuristic. I'm still waiting for the self-driving cars, so maybe we'll get there one day. But these are the 3 levels of autonomy that you also need to keep in mind going forward. If you're thinking about what's your 2030 development strategy, you need to think about what level of autonomy of agents you have in mind. But I promised you a little bit of telling you a state of the union, where are these LLMs? And I showed in the morning a little demonstration of converting a Figma design of a consumer drone UI, this thing, into essentially QML code and generate then test cases, GUI test cases, code documentation, all of it. And I promise you to give you a little bit of scenes of what they can actually do. And the most challenging task here for this agentic AI, even that this was all live code, real prompts, real LLMs acting to the best of their ability, it showed some limitations. I couldn't show all of them, but I'll give you a little bit of idea of what they can do. So if you think, for example, here this consumer drone UI, if you take, for example, the battery icon up there, when you ask it separately, you give it a screenshot, and you ask separately, can you create me that QML code for the battery icon? What you will get is this. So that's kind of useful already, right? I mean, yes, the color of the text is wrong, and you need to stretch a little bit that battery icon. Not too bad. This is actually useful. With essentially two little changes, you're exactly there where you want it to be. And this is, again, created by 3.7 Sonnet. So you can retry that one. It will work. And the beautiful thing is actually Sonnet creates this battery icon even in a logical correct way with the business logic. So it has actually a property for the battery level in there. So it will move the progress bar, the green bar, based on that one property it creates on how full the battery is. So it has understood it's a battery indicator, so I need to have that value and moves that. So that's pretty useful already. Well, why would you want to bother that one? But here's another one. If I look at the throttle control of how fast the motor should run, what we wanted to have is this, and what we got is, well, reality. It got this, yeah, it created at least a slider. Good, so I don't need to. But yeah, the anchors are a little bit off. And this is not untypical for today's state of the union of LLMs. Their spatial thinking is still to a very large degree limited, in particular with QML, placing anchors, even that it knew where it needs to place things. I mean, had the image and it had the metadata, it still struggles of getting it even nearly right, and it didn't get the colors of the frame around it correctly, and even the handle for the slider is incorrect. So you're probably faster doing this yourself than asking the LLM to do it, right? I mean, and I can't even show you all the code being generated, what that would lead to in reality. Because if you ask it to generate code, first of all, every time I demonstrate that, it gives me a different result, right? You have to remember, this is probabilistic. This is not deterministic. Every time, even you get exactly the same screen capture, the same metadata in there, it will generate you a different result. You can narrow it down with the prompt of what you wanted in terms of structural, Qt project, repeat certain things, but it will create you different results. So there's not one answer. And you will find also that since there is many, many lines of code in multiple QML files, it rarely compiles right after the box. So I'm not going to draw reality, because reality is without fixing some stuff. In average, you might get lucky 1 out of 10 that out of the box it compiles. It will not work. But still, there's a lot of things that you can do already. And reality is in the agentic AI demonstration today is that all of the code has been generated with real prompts, with large language models, and some of the functionality is reality. I mean, the code documentation that you saw, the markdown documentation, this is existing functionality of the Qt AI system. We didn't do anything to it. We just do it. If you think about the functionality of creating Qt quick tests, you saw the prompt already earlier. This is reality. This is stuff you can do today. So the state of the union is there's a lot of things you can do already. Of course, some of the more complex tasks, taking whole Figma design and getting it right in one shot, is really, really difficult. I don't know what it will take to solve these kind of complex issues. Currently, the LLMs are very good in object level, function level, method level kind of code creation, but when you talk class level, not to mention whole project level complexities, you can give them a lot of context. They will still not get it right. So this is not reality, and you will see that they are struggling. And I haven't seen the breakthrough either yet in terms of doing this thing. So it can do these things, right? I mean, it can write the code documentation. If you try out the Qt AI Assistant, it will do that for you. So this is existing functionality, and Qt AI Assistant is developing further. It has its roadmap. I will not go into details of what the roadmap will look like, but I'll tell you a little bit more of what I expect when I think it's a 1.0. Currently, I think we're 0.91 or something. When I think of 1.0, what we need to still is we need to feed it more context. Currently, we're feeding it typically only the open project. We need to have chat memory in there. Currently, we're doing a single shot because most of the LLMs, they don't have a memory on their own. So you need to buffer that knowledge in background. And of course, if you have a conversation over 50 messages at some point, you need to summarize that knowledge again and start over. But that's something you need to have. And we need to have some kind of static code cybersecurity check automatically inbuilt, at least to some level, before I say, okay, we are done. But it's exciting times. And if I summarize, ultimately, if you think about an expert LLM like CodeLlama 13b, these are very, very good in helping you in code completion. You don't need to spend the money on Sonnets, OpenAIs, or DeepSeeks for getting that job done. They're very good in this is doing, and they can run in your privacy, and you have almost all the benefits for very good code completion as it is. But this human-AI collaboration can help you generate a lot of productivity gains, code documentation, unit test case, even getting good started Qt project from a conversion from Figma design. These are the things that will speed your work up, not to mention the expert help that I mentioned earlier. So there is significant improvement. It's not a genie we're going to put back in the bottle with Gen AI and software development. But it will take a lot of time, and I haven't seen it yet. Maybe it's tomorrow, who knows? I didn't see DeepSeek's mixture of experts technology coming around either, and all of a sudden it was there. But in the last 2.5 years that I've looked at these things, I have not seen any technology breakthrough on top of transformer architectures and the attention model that would take the models to be able to solve more complex issues, understand UIs much better. So maybe it's tomorrow, maybe it's in 5 years, I don't know, maybe it's never. But there's significant breakthroughs necessary for the human to take a significant step back in creating good software. So that means for you, software developer, whether you're new to Qt or whether you're already experienced developer, there's never been a better time to develop Qt applications, to build your knowledge, get better, because you're going to get more productive with Gen AI. You will stay in control of it, because remember, AI is good, human is better. Thank you.